everyone, we're going to be looking at section 2.2 today. We are going to skip the first page of the 2.2 notes, so you can just skip those, and we're going to go straight into where it says discover. So in previous sections, we worked with mean or average as a measure of the center of a data set. Many times the data values do not have the same importance, which affects how the mean is computed. So we are going to look at how we deal with situations like this. So starting with the definition. And also just to make sure that we understand, mean is just a different word for average. So average and mean have the same meaning. So a weighted mean is an average in which some values carry more significance or more weight than others. To find the weighted mean, you will multiply each value by its weight. Then you will add these values and divide the total by the sum of the weights. And here is a visual to help you explain what we just said in words. Another tidbit that I have is weight is also the same meaning as frequency. So if you ever see the word frequency, it has the same meaning as the weight. So in our first example, it says, let 3, 4, and 5 be the data values. Suppose that the 3 carries twice as much weight as the 4 and the 5. Find the weighted mean. So I'm going to have us make a table here. We're going to put the values that we are dealing with, and then we're going to put their weights. The values that they listed are 3, 4, and 5. It says that the 3 carries twice as much weight as the others. So the 3 carries a weight of 2, whereas the others just carry a weight of 1. So we're going to do our setup, which is to take the first value times its weight. So I'm going to create a fraction bar. On the top, the first thing I'm going to multiply together is the first value times its weight. So I'm going to do 3 times 2. Then I'm going to add the second value plus its weight. So that would be 4 times 1. And I'm going to do that for the rest of them, which we only have one left, which is 5 times 1. The bottom is going to be the sum of the weights. So you're just going to add up all of the weights. So it's 2 plus 1 plus 1. Okay, we're going to multiply within the parentheses first. So 3 times 2, we would get 6. 4 times 1 would be 4. 5 times 1 would be 5. So when we get the top, we have 6 plus 4 plus 5. The bottom, if we add up the bottom, we get 4. So this would be 15 over 4, and we're just going to divide. So we get 3.75. Example 2, we're going to do in a really similar way. It says find the weighted mean of 15, 25, and 250 if 15 carries 4 times as much weight as each of the other values. So we will do a table again. We'll have our values and then the weight. So values are 15, 25, 100, 250. It says the 15 carries 4 times as much weight as the other values. So this one would be 4, and the rest would just be a weight of 1. Okay, so for our setup, we're first going to take the first value times its weight. So that will be 15 times 4. Then we will take the next value times its weight. and keep doing that with the rest of them. For the bottom, we're just going to add up all of the weights. Okay, so if I multiply the top together, this would be 60, 25, 100, 250. So I'm going to add up all of those. And the bottom is going to be divided by 7. Okay, so if we add up all of the top, we end up with 435. And if I divide by 7, I get, and we'll just round to 2 decimal places, 62.14. With this chapter, you'll want to make sure that you're careful to look at what you are going to be rounding to. All right. Weights can come in many forms. It is not always obvious when a mean is weighted or what the weights are. When finding any average, look for information that indicates whether or not the numbers being averaged are equally important. Okay, so we've really looked at all of the steps involved in this, so I'm going to have us skip writing out exactly what the steps are. Or just So looking at example 3, it says at a department store, there are 20 employees who earn $18.75 per hour, 5 employees who earn $22 per hour, and 100 employees who earn $9 per hour. We want to find the average hourly wage per employee. So because we're finding the average hourly wage, our values are going to be the wages. The weight is going to be the frequency or the number of people that have that wage. So to begin, notice that there are different numbers of employees at each hourly wage. Because of that, the hourly wages cannot be averaged by themselves. Instead, the number of employees weight the wages. So with this, we can't just add up all of the wages together, $18.75, $22, and $9, because there's a different amount of employees that are each at that wage. So what we want to do is we want to take each of the wage values and have its weight as the number of employees at that. So this one would be 20. We would have $22 would be 5 employees. And the $9 would be our 100 employees. So we're going to take each of the wages, so $18.75 times the weight, that one would be 20. Do that with the next one and the last one. On the bottom, we're going to have the sum of the weights. So you're going to add up all of the weights. Whoops, we're going to add. Okay, if I multiply this, I get 375. This one multiplied will be 110, and this one multiplied will be 900. So if we add up all of those, we get 1,385. And if we add up the bottom, we get 125. If we divide, we will get an answer of $11.08. For example 4, it says the following data represent the ages and years of cats at a shelter. We're going to find the average age of the cats. Instead of entering the values into your calculator separately, because if we were to add up all of these, we'd be adding up a lot of numbers. We're going to use the frequency of the ages to find a weighted mean. The table is going to help us organize our work. So we're going to list all the different ages. So these ages will represent the values. So if I look here, I've got ages 1, 2, 3, 4, 5, 6. We don't have any that are 7. We have 8, 11, and 15. And it is okay that I have one extra row. I'm going to just use that for like a total. So the frequency, remember, frequency is also just another word for weight. So we're going to look at how many of 1 we have. So if we count how many of 1, there are 7. If we count how many of 2, we have 3. How many 3s? We have 10. For 4s, there are 4. For 5s, there are 11. For 6s, there are 2. And then for the rest, we just have 1 of each. Okay, instead of doing this table by table, so instead of doing this value by value using a fraction bar, like 1 times 7 plus 2 times 3, instead of using all of that, what we're going to do is we're going to allow the table to help us out. So we're going to, instead of multiplying them all out using the fraction, we're going to go ahead and just put what they would be multiplied right here. So these are just going to go right here in this column. So I'm going to take the age times the frequency. So 1 times 7, I get 7. 2 times 3 is 6. 3 times 10 is 30. 4 times 4 is 16. 5 times 11 is 55. 6 times 2 is 12. And those are just times 1. Okay, to add up all of these will give us what we get for the top. So this all added together is 160. So that's going to be what I get for the top. For the bottom, that is just going to be what 7 plus 3 plus 10 and so on is. That's going to be this spot, the weight. And if I find the total of that, which is 40, that will be my bottom. So all I have to do now is just divide. So I get 4. So the average age of cats at this shelter are 4 years old. In addition to means and weighted means, there are other measures of center that we use for data. 2 such measures are the median and the mode. So we're going to go into what both of those are. The median of a set of data is the middle value. When the data values are arranged in order. That's one of the biggest things, is you want to make sure that you have them in order. You don't want to just find the middle value of just a random list. You want them to actually have meaning, so have them in order. So if we put these in order, we have 72, and then 74, and then 76, and then 78, and then 80. Now we want to find the middle by crossing out the ends until we get to the middle. So if we cross off the first, we'll also cross off the last. Cross off the new first, crossed off the next last. So we end up with 76 in the middle, which would be our median. However, there can be a special scenario with this. If there are an even number of values that you are listing in your data set, the median is found by averaging the 2 middle numbers. So what you will do is you'll take the 2 middle numbers, add them together, and divide by 2. That will give you your answer. So if we now have this set of data, we've got 72, 74, 76, 78, 80, 88, and we try to find the middle of that set. This time, we don't have one number in the middle. So this time we're going to take the two numbers in the middle, add them up, and divide by 2. When we get that, we get 77. The mode is the most common value or values in a set of data. Data sets can have no mode, one mode, or more than one mode, just depending on the scenario. So if we look at this data set, 76 appears more than any other number in our list. So 76 would be our mode. When we look at this one, 74 appears twice, but we have 76 appear 3 times and 80 appear 3 times. So 76 and 80 appear the most. And because it's a tie, 76 and 80 are our mode. It does not matter that 74 repeated twice because 76 and 80 repeated more. In this one, none of the numbers repeat, so there is no mode. Everyone is just as popular as the other ones. So for example 7, it says, find the mean, mode, and median for the data set of ages of college students in a small study group. And we're only going to do the first part. We're not going to worry about the second part of this. So we've got 17, 18, 19, another 19, 20, 22, 24, and 25. I apologize about that. Sometimes my dog likes to bark. So let's go ahead and find the mean. If we are just finding the mean and this is not an weighted average problem, we're just going to add up all of the numbers. And if we add up all of the numbers, we get 164. And we're going to divide by how many numbers there are. So if we count, we have 8. So we get 20.5 for the mean. For the median, we're going to find the middle. So if I cross off the ends until I get the middle, I've got 19 and 20 that are left in the middle. I can then take that divided by 2, so I get 19.5 for the median. For the mode, we're going to find any numbers that repeat or show up more than others. The only ones that repeat are 19. So that one is the most popular, so we have mode. The last type of problem that we're going to be looking at for this section is going to be looking at GPA. So, grade point averages, or GPAs, are computed as weighted averages in which each course grade is weighted by the number of credit hours for the course. So for a course like Math099, it is worth 5 credit hours, so it can be weighted more than other courses. So we're going to use this information in the tables to calculate the student's GPA for each semester. We are not going to worry about cumulative GPA, so you do not have to worry about that. Okay, first thing that you want to know is that grades are going to be represented by a number. So an A is worth 4 points, a B is worth 3 points, C is 2, D is 1, and an F is 0 points. So what we're first going to do is we're going to replace these values with a number. So a C is worth 2. So anytime we see a C, we're going to have that worth 2. A D is worth 1 point. And a B is worth 3. So when we look here, the weight is the number of credit hours. Our value is our grade. So that's really important that you remember that the weight is the number of credit hours. Okay, so we're going to take each value times its weight. So I'm going to take 2 times 3. Then I'm going to do that for the next. 1 times 6. 3 times 5. and 2 times 3. Okay. For the sum of the weights, you're going to add up the number of credit hours. So it's going to be 3 plus 6 plus 5 plus 3. So if we multiply inside the parentheses here for our credit hours, we get 6, 6, 15, and 6. If we add all of them up together for the top, we get 33. If we add up the bottom, we get 17. So to find the GPA, you're just going to take the top divided by the bottom. So we get 1.9411, and it keeps going in our calculator. With GPA, we're almost always going to round to 2 decimal places. So this would be 1.94. Okay, we're going to go ahead and do one other example. We'll go ahead and skip down to part C, where we look at the fall semester of sophomore year. So first, let's go ahead and change the grades to be values. So any A's will be worth a 4. B's will be worth a 3. Remember that these are the values and these are the weight. So I'm going to take 4 times 3 for the first, and then 4 times 3 again, and then 3 times 4, and then 4 times 3. Make sure that for the bottom, you're adding up the credit hours for the sum of the weights. So we get 3 plus 3 plus 4 plus 3. Okay, if we multiply the inside for the tops, we get 12, 12, 12, and 12. And if we add all of those together, the top will be 48. The bottom will be, if we add up all of the bottom together, we get 13. Okay, we're going to go ahead and divide. In the calculator, it shows up as 3.692. We're going to round to 2 decimal places, so it will stay 3.69. Okay, this gives you everything you need to know for section 2.2. If you have any questions, please feel welcome to reach out.